In the last video, we finished building the on-screen display and scoring logic. Today we'll build the sound section and amplifier. For the sound section, we'll need a 74193 in Fox 6, a 7410 in Jack 9, 74123s in Able 7 and Able 8, and a boatload of passives. We'll be here for a while. We also tapped a line out off the audio bus, ran that through a DC blocking capacitor, and connected it to an onboard RNC jack. One of our goals was to replace all legacy board 9000 series chips with 7400 series. Here we're replacing 9602s with 74123s, which are not pin compatible, nor are they 100% logically equivalent. The 123s use an AND trigger while the 9602s use an OR. This was not an issue because all instances only use one input. We just needed to make sure we tied the other inputs to the correct levels. The other logical difference was the fact that the reset line on the 123s also tie into the trigger. So if the circumstances are right, de-asserting reset could re-trigger the one-shot. We only had one instance of this issue on the brick hit counter, where the circuit was re-triggered when the machine came out of attract mode. This put up fake points when you start a game. We were able to suppress this re-triggering by tying one input leg to what we call the can hit bricks line. This only allows a circuit to fire under the right circumstances. This was the only logical change we needed to make to the entire design. The 123s also have slightly different timings, but the difference is not material in this design. I also find it interesting that the LS part timing is slightly different than the base TTL part. Go figure. Try that out. Well, we finally have our sound back. The bricks are still hanging around because I didn't tie off those FSD lines. We'll just call this the infinitely difficult mode. Let's work on that amp. We'll need an LM380 and Able 9, the 10K pot R50, the 0.1 mic low pass filter C35, the 0.1 mic DC blocking capacitor C30, the 100 picofarad differential input stabilizer C-4, the 1 mic internal bias voltage stabilizing filter C29, the output protecting Zober pair made up of R49 and C28, and the output coupling capacitor C31. And yep, C-4 was not a typo here. The original site name for this capacitor was C4, but that collided with chip site C4. We kept C4 for the chip and stuck the dash in there for this cap. Perhaps not the best solution, but that's what I did. We had 3 total collisions that required similar treatment. We're also going to need 12 volts to power this amp. In the cabinet, it would be powered from V-Unreg, but we don't have V-Unreg yet, so for this test, we need to get 12 volts into here via the onboard barrel jack. We'll test the other power options later. In the power section on sheet 4, we therefore added CR101 to isolate the amp supply, the 470 mic filter C31, the 12 volt barrel jack, and an LED indicator and associated current limiting resistor. I had made a custom dual footprint for that volume pot, so you could drop in a common 9mm horizontal or vertical part. I placed this on the card edge side so it was easily accessible when installed in a cabinet. You basically have to pull legacy cards out of the cabinet to change the volume. While installing parts, I noticed that I screwed up that custom footprint for the volume control pot and switched the wiper ends. So counterclockwise rotation makes it louder. Yeah, I screwed that up on purpose so that the building inspectors would have something simple to find. Sure I did. I got a new slightly less crappy speaker and hooked it up to the terminal posts on the control card. I also plugged in a 12 volt adapter. Just make sure you don't plug 12 volts into the 5 volt jack. That would be a bad year. Yep, that crappy speaker is crappy, but the amp works. I still love those retro tones. Okay, we're done with this section. In the next video, we'll do the coinage and credit circuits. We're almost there. Thanks for watching.